Okay, we want to select the pairs of ratios that form a proportion. Okay, for things to be proportional, okay, they need to form the same kind of a ratio. So we can check this 4 over 9 and 16 over 36. Okay, we can check this by doing a couple of different things. Number one, we can check to see whether or not if we reduce the fractions that they end up being the same. So since 4 over 9 can't reduce, we're going to leave that the same. 16 and 36 can be reduced. Both are divisible by 4. If we divide both by 4, we end up seeing that this is going to end up being 4 over 9. So because we have 4 over 9 and 4 over 9, we have the same fraction. They're in the same ratio as each other. It means our first answer choice here is going to be correct. Okay, so let's go ahead and check some other ones here. So when we look at this, we can also see that we have 18 over 5 and 7 over 2. Okay, looking at this, I can automatically see this is not going to work. If I try and reduce both of these, okay, it's not going to end up being the same. 18 and 5 don't have any numbers in common. We can't reduce those. 7 and 2 don't have anything in common. We can't reduce those. We can also check to see whether or not they are equal to each other. So we can do our division and say 18 divided by 5 is going to be equal to 3, and then 3 over 5 is going to be equal to 0.6. So we have 3.6, whereas over here, 7 divided by 2 is going to be equal to 3.5. And because these two things are not equal to each other, they are not going to be proportional. So the second one is not going to be one of our options. Okay, then looking at the next one, okay, we see that we have 10 over 45 and 2 over 9. Okay, so again, we can simplify this and simplify this. 2 and 9 don't have anything in common, so that's as simplified as it gets. We can divide both 10 and 45 by 5, and we're going to end up with 2 over 9. And since these are equal to each other, that means that this is going to be a good one. So we're going to see that, yes, that third one is going to be an option for us to pick. And then looking at the last one here, we have 16 over 9, and we have 11 over 6. And checking this, we can say, does anything go into 16 and also go into 9? No, there's nothing that works here. Is there anything goes into 11 and also goes into 6? No, so there's nothing that's going to reduce there. Okay, we can check our work by checking the division, and because these are ugly divisors, we're going to end up with repeating decimals, so it's probably easier to use our calculator at this point. So we can use our calculator. We can use 16 divided by 9 is going to be equal to 1.7 repeating. So I'm going to have 1.7 repeating. And then for my other one here, we're going to see that this is going to be 11 divided by 6. And we're going to see it's 1.8, then 3 repeating. So I can say, okay, this is going to be 1.8, and then 3 is going to repeat. And because, again, these things are not equal to each other, they are not going to be proportional, they are not going to have the same ratio as each other. So we're going to say, no, this one is not going to work out for us. Now, there's a couple other ways that we can do this. We can use a cross products method. So looking at this 10 over 45 and this 2 over 9, we can actually do cross products. What we mean by cross products is that we'll do 10 times by 9 gives us 90, and 45 times by 2 also gives us 90. And because this cross products works, okay, it's just like reducing this fraction. Because this cross products works, we can know that they are proportional.